Good day wherever you are. Let me take you through industrial processes in chemistry, paper 1 and paper 2, because this question can be in paper 1 or paper 2. So, but in paper 2 we know this process will not be there. So we just want to revise generally. So the first process we want to look at is the HPR process. As we know, the HPR process is the industrial manufacture of ammonia gas. So whenever you hear HPR process, it is the industrial manufacture of ammonia gas. Kwa hivyo kitu nafaa kujua in these processes kwanza ni the raw materials. Very important, because once you know the raw materials, you know where the process begins. So the raw materials in the HPR process, it is they include nitrogen and hydrogen. Very good. So these are the two raw materials that are used in the HPR process: hydrogen and nitrogen. So these are the raw materials that are used there. Now again, another thing you need to know, where does the nitrogen that is used in the HPR process obtained from? The nitrogen used in the HPR process is obtained from the fractional distillation of liquid air, right? Where do we get the hydrogen that is used in the HPR process? It is gotten from the cracking of alkanes. It is obtained from the cracking of alkanes. Here, they are cracking of alkanes. During cracking of alkanes, hydrogen gas is produced, and that hydrogen is used in the HPR process. So let us begin now the process itself. Once we have known the raw materials, the other thing we need to know is the catalyst that is used there in the HPR process. You should know the impurities that are removed. Those are the major, and then you should know the reaction in the catalytic chamber. Then the temperature and the pressure. Very fine. So the process, nitrogen and hydrogen gases are mixed in the ratio, that's not very important. Passed through a purifier. That is now very critical. The mixture now, nitrogen and hydrogen, is passed through a purifier. A purifier, the work of the purifier is to purify. To purify means to remove impurities. So the work of the purifier is to remove impurities. What is the effect of impurities in this process? If these impurities are not removed, they are going to poison the catalyst. So the impurities are removed in the purifier to ensure that the catalyst is not poisoned. So impurities are removed which could otherwise poison the catalyst. Now we are at a point where we should know the types or the names of the impurities that are removed. In the HPR process, the impurities that are removed includes carbon 4 oxide, sulfur 4 oxide, and dust particles. So if you are asked the impurities that are removed in the HPR process, number 1, carbon 4 oxide, sulfur 4 oxide, and dust particles. Very good. The next most important thing we want to know is the name of the catalyst that is used in the HPR process. The mixture of nitrogen and hydrogen is then compressed to a pressure of 500 or those things, and then ionic catalyst is used. Remember, different processes use different catalysts. That's why it is important that you know the name of the catalyst. So ionic catalyst is the one that is used in the catalytic chamber. The reaction is highly exothermic. Exothermic means that it produces a lot of heat and sustains the temperature in the catalytic chamber. So another thing that is important for you to know is the reaction in the catalytic chamber. So the catalytic chamber, nitrogen and hydrogen combine to give us ammonia. So this is the equation which you must know how to write and balance. In the catalytic chamber, nitrogen and hydrogen combine now to form ammonia gas, producing a lot of heat. The hot mixture of ammonia and gases which have not been reacted is passed through the heat exchanger where cooling takes place. Very important to know what happens in the heat exchanger. In the heat exchanger, the unreacted gases, the heat that they come with from the catalytic chamber is removed in the in the heat exchange. The heat is used to heat the incoming mixture of nitrogen and hydrogen. This makes the process economical. So let us now look at the diagram itself. Nitrogen, these are the raw materials. They get into the purifier. In the purifiers, you can see the impurities are removed. We have said the impurities are removed. And then the two gases, now the mixture is compressed to atmosphere, 500 atmosphere. Then it goes to the catalytic chamber direct. From the compressor, it goes to the catalytic chamber where the temperature is 500 degrees Celsius. In the catalytic chamber, and I mean nitrogen and hydrogen combine to form ammonia gas. Now the ammonia formed goes through this one to the heat exchanger where the heat is removed. Here also there is those gases that have not reacted. Nitrogen which has not reacted, hydrogen, they go through the heat exchanger where the heat they come with from the catalytic chamber is removed. The heat that is removed here from this unreacted nitrogen and hydrogen is used to heat the new nitrogen and hydrogen that's coming. And then it goes through the condenser where the ammonia is, the hot ammonia is condensed, is cooled, and then collected as a liquid ammonia. Now the unreacted gas, they go back to the compressor and then they again come the process like that. So the process goes round. And then you should know some uses of ammonia. Ammonia is used as a vaporizer, a manufacture of nitrogenous fertilizers, is used as a refrigerant, used in softening water, removal of grease stains, manufacture of hydrazine that is used in rocket fuel. So at least know 2 uses of ammonia and you will have on a better. The second process we want to look at is the Ostwald process. Ostwald process is the process of the industrial manufacture of nitric 5 acid. Ostwald process is the process where nitric acid is manufactured in the industry. So the first thing we need to know, as I've told you, is the raw materials. Kwanza lazima ujue the raw materials in the process. So the raw materials in the Ostwald process is the ammonia gas, air, and the water. So the 3 raw materials very important is ammonia, air, and water. Una realize kwamba hii question huwa inakuwa combined because this one is used to produce ammonia hapa process. So wana combine hapa process na Ostwald process, Ostwald process wana combine and then unachanganyikiwa kwa nini? Because once hiyo inatupa the other one will give us ammonia. That ammonia is needed in the Ostwald process. So air, the mixture of air and ammonia now gets into the purifier. The work of the purifiers remains the same, is to remove impurities. Again, hapa lazima ujue the impurities that are removed in the Ostwald process, industrial manufacture of nitric acid. Lazima ujue the impurities that are removed here. They might not be the same as the one was removed in the HPR process. So before we go through the diagram, let us just go through some few notes here. A mixture of ammonia and air is first purified. Why is the mixture purified? To remove dust particles and other impurities. So other impurities, leave them alone. Just know in the nitric industrial manufacture, dust particles is one of the impurities that are removed. And then the reason why the impurities are removed, like the other one, is to avoid poisoning the catalyst. Otherwise, if the particles are left there, they will poison the catalyst and the process will not proceed. The mixture is then compressed to a pressure of 9 atmosphere. The mixture is then compressed to a pressure of 9 atmosphere and passed on to the catalytic chamber via the heat exchanger. As it passes through the heat exchanger, the temperature of the ammonia air mixture rises to 230. Nilikwambia ni nini unafaa kujua in any process. Ni the raw materials, the temperatures, the atmosphere, the pressure, the catalyst, the impurities which are removed. So here, the catalyst that is used in the Ostwald process, industrial manufacture of nitric acid, is called platinum rhodium catalyst. The catalyst that is used is called platinum rhodium catalyst. Very important to note. Very good. And then now in the catalytic chamber, there is this reaction which takes place there, which you must know in the catalytic chamber. So let us go back to the diagram. So ammonia and the air gets into the purifier, the impurities are removed. Now the ammonia plus air goes into the compressor where it is compressed under the atmosphere of 9 atmospheres, and then it goes through into the heat exchanger, through the heat exchanger to the catalytic chamber. So in the catalytic chamber now, nitrogen 4 is nitrogen 4 oxide is formed because the reaction in the catalytic chamber is ammonia combines with oxygen in the presence of platinum rhodium catalyst to form nitrogen 2. This gas here is called nitrogen 2. So hii ndio gas inakuwa formed in the catalytic chamber. Sasa ikishakuwa formed in the catalytic chamber, hiyo gas inarudi to the heat exchanger where some heat is removed, and then that heat is removed. So now we have cool nitrogen 2 oxide and air. Now this air which is going to oxidize nitrogen 2 to nitrogen 4. So here what is entering in the reaction chamber is nitrogen 4. So now nitrogen 2 inaingia kwa reaction chamber, inaongezewa air, purified air. Now it will react with nitrogen 2 to form nitrogen 4. That's oxidation of nitrogen 2. And then unreacted nitrogen 2 is taken back to the compressor, and then absorption is done. Absorption is done by adding warm water. This is warm water that is added here into the nitrogen 4 oxide to form 65% nitric 5 acid. Now, what is the reaction in the reaction chamber? The reaction in the reaction chamber, nitrogen 2 is oxidized to nitrogen 4. Very important for you to note the reaction in the reaction chamber. Air, which is oxygen, reacts with nitrogen 4, reacts with nitrogen 2 to form nitrogen 4 in the reaction chamber. Sorry. What else is that is very important here? Now it is the reaction in the absorption chamber, in the absorption tower. In the absorption tower now, nitrogen 4 is added to water to form nitric 5 acid and nitric 3 acid. So in the absorption chamber now, this is the reaction that takes place. Nitrogen 4 plus water forming nitric 5 acid and nitric 3 acid. Now the nitric 3 acid is oxidized by oxygen to form nitric 5 acid. And this is the oxidation part of it. Next process I will take you through is the flash process. The flash process is the process where sulfur is extracted from its from the ground. So the flash process is employed in the extraction of sulfur The process is based on the low melting point of sulfur, which ranges between 113 degrees to 119. In the flash process, 3 concentric pipes of different diameters are sunk into the sulfur deposit underground. That's not very important. What's very important is now for you to know the 3 concentric pipes that are sunk into the ground. We have 3 concentric. We have the outermost, this one. We have this one here. We have this one. This one is the outermost. And then we have the innermost. This one is the innermost. And then we have this one. Nataka uone hiyo tofauti. So, the innermost, what goes through the innermost is the compressed, hot compressed air. At 15 degrees, 15 atmospheres, hot compressed air goes through here, the innermost. Alafu, the outermost hii ya nje, kitu inaingia hapo ni superheated water at 170 degrees Celsius. Na lazima tujue the work of the superheated water and the work of the hot compressed air. And then sasa hii ni mahali sasa inatokelezea. Sasa ile ikisha hiyo pressure ikitoka hapa juu inaifinya, inapanda, alafu inatokelezea hapa, inakuwa collected huko. So this is what happens. This pressure, this water ikishawekwa, because it is very hot, it is superheated to 170, inaingia, ina melt the sulfur. Sawa? Ikisha melt the sulfur, now wanaweka hii pressure, hot compressed air, inapoteremka hivi, sawa, inafanya hii melt sulfur inapanda, kwa sababu hiyo pressure inapanda. So inapopanda, nini inafanyika? Inapata hii mwanya na inafanya nini? Inatoka, inakuwa collected. Water is heated to about 100 under pressure of this and forced into the outermost pipe. The pressure ensures that the water remains in liquid state. Okay. I think I have said the reason, the reasons or the purposes of hot compressed water is to melt the sulfur. The hot compressed is to ensure that the mixture, the hot compressed, this one is to force, is forced down, and then it is going to force the molten sulfur up to the ground. Next one is the contact process. The contact process is the industrial manufacture of sulfuric acid. Industrial manufacture of sulfuric acid is called the contact process. And at the same way, what you need to know in any process is the raw materials. The first thing is the raw materials. So the raw materials in the contact process is sulfur and air. Air, here we talk about oxygen. So these are the raw materials, sulfur and air. Sulfur and air are the raw materials. Now this one, they are not taken to the purifier first, but they are burned. So after burning, they form sulfur 4. Here now sulfur 4 is formed here. And now sulfur 4 is the one that is taken to the cleaner and the dryer. So now the cleaner and the dryer here, cleaning meaning purification, and then the air is being dried. So the raw materials is in the contact process are sulfur and air, not sulfur 4, actually it is sulfur. So forget about this sulfur 4, it is sulfur. The raw materials is sulfur and air. Now sulfurs are burnt to produce sulfur 4 oxide. Yeah, now sulfur burns with air to form sulfur 4 oxide. The impurities were produced, so the impurities are removed to avoid poisoning the catalyst. Like we have said, the impurities are removed to avoid poisoning of the catalyst. The dust impurities are removed by electrostatic precipitation. The mixture of gases now is passed through concentrated sulfuric 6 acid in order to dry the gas. After purification, the gases mixture are preheated in the heat exchanger to attain the stable reaction temperature before being passed into the catalytic chamber. So sulfur plus oxygen, it forms here, we form sulfur 4 oxide. Sulfur 4 oxide is taken to the clean for purification, and then from there it's taken to heat exchanger. Here in the heat exchanger, this gas here now is going to attain the required temperature and then taken into the catalytic chamber, where now sulfur 4 oxide combines with oxygen in the catalytic chamber to form sulfur 6. This one is called sulfur 6 oxide. Now say sulfur 6 oxide, then it's taken back to the heat exchanger and then into the absorption tower. Then what happens in the absorption tower? Hot concentrated sulfuric acid is added to form oleum, and this is the formula for oleum. Oleum now is taken to the dilution chamber where water is added to form sulfuric acid. Now we want to mention the catalyst that is used in this process, which you must know. I have said every process you must know the catalyst that is used, except those that don't use the catalyst, like the flash, there is no catalyst, and the solvay process there is no catalyst. Now here the catalyst in the contact process is called vanadium 5 oxide. This is the catalyst. The catalyst used here is called vanadium 5 oxide. So you need to know that very well. If you don't use vanadium, you can use platinum. Remember, this one is simply platinum. Ile ingine tulikuwa tunasema platinum rhodium. So usilete kuconfuse huko. Kwa sababu ya kuconfuse, wachana na hii jina platinum, tumia vanadium. For contact process, we will use vanadium 5 oxide. Vanadium 5 oxide as the catalyst in the contact process. The other business to know here is the reactions in the catalytic chamber, the reaction in the absorption tower, the reaction in the dilution chamber. So this is the reaction in the catalytic chamber. Tafadhali lazima ushike na uandike hivyo. And then I will take you through the reaction in the absorption tower, where sulfur 6 reacts with concentrated sulfuric acid to form oleum. Oleum is H2S2O7, and this is the reaction in the absorption tower, in the absorption tower. And then from there we go to dilution, the dilution chamber, where water is added to oleum to form sulfuric acid, and this is the equation in the dilution chamber. Sulfur 4 oxide, some of the sulfur 4 oxide escapes to the atmosphere. We know the effect of sulfur 4 oxide in the atmosphere because it is an acidic gas, so it is going to react with rainwater to form acidic rain. So we don't want that. We need to remove it from there. How do we remove that? We remove it by doing what we call scrapping of sulfur 4 oxide. How do we do scrapping of sulfur 4 oxide? We react the sulfur 4 oxide with calcium hydroxide, where it is going to form calcium sulfite and water. And by so doing, we remove that. We avoid sulfur 4 oxide going into the atmosphere. That is when this process is called the scrapping of the gas. solvay process. The raw materials in the solvay process is brine. Brine is actually concentrated sodium chloride, ammonia gas, very important, and then carbon dioxide from limestone. Carbon dioxide, you can say limestone, and then there is coke. Coke and limestone kazi yao ni kutupea carbon dioxide, because this reaction cannot take place without carbon dioxide. So in the solvay process, I've said that you first know the raw materials. The raw materials is brine, which is sodium chloride, and then calcium carbonate, and the coke, which are the sources of carbon dioxide that is very important in this process. So calcium carbonate is calcium carbonate which is heated to form calcium oxide plus CO2, and that is what is required. Also carbon is called the coke, which is heated carbon plus oxygen to form carbon dioxide. Then ammonia gas is required also, and it is obtained from the HPR process, and that is another raw material. So these are the three major raw materials that we need in the solvay process. So to understand the solvay process, it is important that you know where the process starts. Mahali process inaanza ni mahali ammonia na sodium chloride inaingia. Na mahali ammonia na sodium chloride inaingia inaitwa the solvay tower. So ammonia with sodium chloride, which is brine, these two enters the solvay tower, where they combine to form what we call ammoniacal brine. Right, sawa? So here ammoniacal brine now, which is a mixture of ammonia plus sodium chloride plus water, gets into the carbonator from the top. So gets into the carbonator. Now in the carbonator, carbon dioxide enters the carbonator. So in the carbonator we have how many things? We have ammonia, sodium chloride, water, and the carbon dioxide. Those four substances react now to form ammonium chloride plus sodium hydrogen carbonate. Ammonium chloride is in solution form, while sodium hydrogen carbonate is a solid. Ammonium chloride is a solution and sodium hydrogen carbonate is a solid. It is taken now to filtration, kuchunga. Now ammonium chloride is being a solution inapita kwa kichungi, inaenda kwa ammonia generator, and then the sodium hydrogen carbonate inabaki kama residue, because filtration we will have the residue. The residue is taken to the roaster. Sawa? The residue is sodium hydrogen carbonate. It is taken to the roaster where it is heated to produce sodium carbonate. In the process of heating in the roaster, sodium hydrogen carbonate produces carbon dioxide which is recycled. So this is a recycling of carbon dioxide which enters the carbonator again. So tumemaliza hapo mambo venye sodium carbonate inatoka. The next thing ni tunataka kujua so now ammonium chloride ina enter the generator here. Ikisha enter hapa inakutana na nini? Inakutana na okay, before tuende kwa generator, wacha turudi back kwa what happened in the kiln. In the kiln, it is where calcium carbonate ilichomwa ikatengeneza carbon dioxide na calcium oxide. Calcium oxide here ikaongezwa maji, water, and this one is called slaking. So here calcium oxide ikiongezwa maji inatengeneza calcium hydroxide. This is calcium hydroxide. Now calcium hydroxide inaingia kwa ammonia generator. Ikiingia hapa inakutana na ammonium chloride. Sawa sawa. Now ammonium chloride, calcium hydroxide in the ammonia generator combines with ammonium chloride to generate now ammonia, calcium chloride, which is this one, calcium chloride, and then water. So the ammonia generated here is recycled. Now this is what you are seeing here, recycling. The thing is, so you will be asked to state some two substances that are recycled in the sulfate process. In the sulfate process, carbon dioxide is recycled. This one is recycled. Ammonia gas is recycled. Even water is recycled. So kitu sasa lingine unafaa kujua is the reactions that are taking place in each chamber. The reactions which are taking place in each chamber, it is important that you know them. So what is happening in the sulfate tower? Ammonia will combine with sodium chloride plus water to form ammoniacal brine. The most important reaction takes place in the carbonator here, in the carbonator. So the reaction in the carbonator is generally this one here, where this reaction here is the reaction that takes place in the carbonator, this, where ammonia combines with carbon dioxide with sodium chloride plus water to form sodium hydrogen carbonate plus ammonium chloride. Ammonium chloride is an aqueous, sodium hydrogen carbonate is a solid. Ndio maana inapelekwa kwa filtration. Ikishafika kwa filtration, ammonium chloride inapita kama filtrate, and then sodium hydrogen carbonate inabaki kuwa residue. Then inapelekwa kwa roaster, inachomwa, inatengeneza sodium carbonate. The reaction in the this is the reaction in the roaster. This one is the reaction in the roaster, where sodium hydrogen carbonate is heated to produce sodium carbonate, carbon dioxide, and water. And these two are recycled. This and this one are recycled. The reaction in the kiln, where this one is the kiln where carbon dioxide is formed. That is calcium plus carbon dioxide. This is the reaction that takes place in the kiln, where calcium carbonate, calcium oxide, where is that? Okay, now this is the reaction taking place in the silica, where calcium oxide is added to water to form calcium hydroxide. Now this is the reaction which takes place in the ammonia generator. In the ammonia generator, calcium hydroxide plus 2 ammonium chloride, it forms calcium chloride, water, and ammonia. Ammonia is regenerated again, then it is recycled. So the only byproduct in the sulfate process is calcium chloride. Calcium chloride is the only byproduct in the sulfate process. Calcium chloride is the only byproduct. Recycled substances is ammonia, water, and carbon dioxide. They are recycled. Then you should know the uses of sodium hydrogen carbonate and sodium carbonate. Uses of this one. It's important that you know them.